let's learn how to solve the questions related to the reactions of benzene, and we will also learn some tricks and tips to solve these questions easily. So first we will see some examples of the benzene question, and then we will learn the tips to solve the benzene questions. So here is our first question, but before we start solving the question, let me be very clear that when you solve a question related to the benzene, you should be able to remember all the reactions of benzene. So you can make a mind map of the reactions of benzene, or else you can see the description to find the mind map of reactions of benzene free of. Also, you can search the other videos of this channel itself, where you will be able to find the reactions of benzene, reactions of substituted benzene, and phenol and its reactions. So you can go ahead and look for the mind map in these videos also. So now let's start with the first question. Benzene can be used as a starting material to produce phenylalanine by two-step synthesis, and the two steps are given here. We can start with the first sub-question. Step 1 is the reaction of benzene with nitronium ion. Complete the mechanism and draw the intermediate of step 1 and include all the relevant charges and curly arrows to show the movement of electron pairs. Now one should also remember that including the intermediate, we should also draw the relevant charges and curly arrows. So starting with the first step, let's draw a curly arrow here, that is an arrow from the benzene to the positively charged nitronium ion. Then draw an intermediate. So here is our intermediate, where we will be drawing a benzene ring first, and then let's attach a nitro group to the benzene along with the hydrogen which was already present on the benzene. Now this shows that the delocalized system of benzene is broken. So we can't draw a circle inside the benzene, but we have to draw a semicircle which covers more than half the benzene. So you should here see that I have drawn a circle which covers, semicircle which covers more than half a benzene with a positive charge at the center. Now draw an arrow from the bond of hydrogen towards the benzene again, and this is the intermediate with two curly arrows here, one curly arrow in intermediate and the first curly arrow in the first step. So we have 2 marks for such structure. We are continuing with the same question, and the next sub-question says, state the name of the mechanism in A1 which we have seen earlier. So now we need to understand that all the reactions of benzene are just electrophilic substitution reaction. So all the reactions of benzene are electrophilic substitution reactions or mechanisms. So that's our answer for 1 mark. Next, identify the reagents needed to produce nitronium ions. Write an equation to explain how these reagents produce nitronium ion. Now, the reagents to produce nitronium ion are concentrated nitric acid, and concentrated sulfuric acid. Now remember, you need to include the concentrated word for this reagent because it needs concentrated acids. Then about writing an equation to produce the nitronium ion, there are few equations which are acceptable, but I am writing here the most common one. Nitric acid reacting with sulfuric acid to produce nitronium ion, and water and hydrogen sulfate ion. In the other words, another reaction which is most common and acceptable also found in your textbook is this one, which is related to the first one itself. Only change which comes here is that it produces hydronium ion rather than water, and so you need to balance it with keeping 2 here in presence of with hydrogen sulfate ion. So you can write any one of this equation. The next sub question is give reagents and conditions for the production of phenylalanine from nitrobenzene. Now the reagents which are needed for such a reaction. Now you know it's a reduction reaction because nitro is converted to amine group. So for such a reduction reaction we need tin and hydrochloric acid. Now these are the reagents, but what about the conditions? Conditions are we need concentrated HCl and also we need heat and reflux of the reagents. So the condition needed are concentrated HCl, heat and reflux. Let's start with the next question which says carbonyl alcohol can be synthesized from benzene by the following route. Now this is the carbonyl alcohol and starting with the benzene. Now here we have series of steps that are 4 steps to form one of the products starting with the benzene. Now such questions are very commonly asked at A levels, and what I suggest here is that just concentrate on what changes are occurring in each step. Once you notice that, then try to draw the structure of the changes which is happening on the benzene, or you can say draw the structure of the group of molecules or the compounds which are added to the benzene. So let's start with the first sub question. It says suggest the reagents and conditions for step 1 to 4. So let's start with the step 1. Now in step 1, what is happening? A part of group of atoms is added to the benzene. Now let's understand what is the group which is added to benzene. Now here you know it's a carbon chain. So let me draw this structure here. Here we have one carbon bonded to another carbon and the third carbon. And this carbon is bonded to 2 of the carbon atom and one bond is with the benzene. So one more bond is left which has to be hydrogen. So CH is here. Here is CH3 and the other group is also CH3. Now that means that a carbon chain is added to the benzene. Now what type of reaction is this when we add a carbon chain to benzene? That's a Friedel-Crafts reaction. Now what's the reagent for a Friedel-Crafts reaction? Whichever group we are bonding to benzene has to be bonded with chlorine. That is the reagent. So for step 1 now we have got the reagent. So let me write this reagent in a simpler form. So I'm writing CH first, this part first, bonded to chlorine, and then 2 CH3 groups. So I'm writing CH3 twice. So this is my reagent, and they have asked for the conditions also. So we need to write the catalyst also, which can be written as aluminium chloride or even iron chloride will do. And such reactions need heating also. So I'm writing heating as one of the conditions. Now let's go with the step 2. Step 2, we have added another group to benzene. Now simplify the structure of this group. What it is? It is a carbon here with a CH3 group on this side and a double bond bonded to this carbon. So again, it's a type of Friedel-Crafts reaction where we are adding a carbonyl group. So again, the carbon which is bonded to benzene should have a chlorine to it. So here is our reagent now, which is very easy to make up. So the reagent is CH3COCl. And again, as it's a Friedel-Crafts reaction, the catalyst is aluminium chloride with heating. Now next is step 3. Now what is happening in the step 3? The chain at the lower end remains the same. Now what is happening is just the side chain on the top is oxidized to carboxylic acid. Now as we know it's an oxidation reaction. So what is the reagent for the oxidation of a side chain of benzene? Now there are 2 types of reagents possible. We can write any one, that is acidified potassium dichromate, or you can also write as alkaline KMnO4. So you can write KMnO4 plus NaOH, and then we have to acidify this reagent. So at the end you can write then H plus also. So this is the reagent for the oxidation of the side chain of benzene. Now step 4. Next step 4. Now what is happening in step 4 is the carboxylic acid is changing to alcohol. So that's a reduction. Now what is a reducing reagent to convert carboxylic acid to alcohol? That is LiAlH4 in dry ether. So that is the reagent to reduce the carboxylic acid to alcohol. So what I suggest here is that in such series of reactions, just keep on watching what change is happening in the next step, and then if such chains or some groups are added, try to draw a simplified structure of these groups and then decide the reagent. This will really help you out and make your question very easy. Let's go ahead with the next sub question. It says, name the mechanism of step 2 and state the type of reaction in step 4. So mechanism in step 2. Now we know that any of the reaction in benzene are always electrophilic substitution reaction. So here again the same question is being repeated, that electrophilic substitution reaction. Now what is the type of reaction in step 4? Now I've already told you that it's a reduction reaction. So reduction, because carboxylic acid is changing to alcohol. Let's go ahead with the next question. Now this type of question is again very commonly asked, and that's the reason that I've covered 3 different types of questions in this video, where you will be able to see and understand how to deal with different types of question of the benzene reaction itself. But again, I'll add one more point here, that along with the reactions of benzene, you need to understand the other reactions, organic reactions also. For example, the organic reactions of AS level chemistry also, if you remember, it is good for you because here few more reactions of other organic chapters are covered. So let's go ahead with question 3. It says, complete the following table to show the structure of products formed and the types of reaction occurring when serotonin reacts with the 4 reagent. Now the structure of serotonin I've given here, and let's see the reagents which are reacting with such a compound. Now generally what happens to the students is that when such a complicated structure is seen by them, they just get confused and think that they don't know anything. But believe me, listen to all the explanation throughout the question, and next time you will find such questions very easy. Now have a look at the first reagent, sodium. Now sodium is a reagent which can react with what? Either acid or alcohol. Now look at your structure and find out that where can sodium react and what do we have in our structure which can react with sodium. Now you can see that there is no acid in our structure. We only have the alcohol part, that is phenol part. So obviously sodium is just going to react here, and the other part of the structure remains as such. So structure of the product I'll draw here in short. I've drawn remaining part of the structure as such. So I've drawn it in short. Now you need to add an sodium just here, replacing the hydrogen. So such a reaction will also release hydrogen gas, which can be seen in the form of bubbles. Now you can write ONA here, replacing the hydrogen, but in some of the answer schemes you may see a negative sign on oxygen and a positive sign on sodium. Both is acceptable. Now what type of reaction is this? You can either call it reduction or you can also call it as a redox reaction, because sodium lost electron and oxygen has gained electron in this, so it's a type of redox reaction. The next reagent is excess bromine aqueous. Now we need to again have a look at our structure. Now let's see that here we have a phenol part, and other than that we have a double bond here, that is C double bond C. You can say that we have alkene group also, and plus we have an amine group too. Here also we have amine group. So out of such 3 groups, which functional groups can react with aqueous bromine? Now think that where is bromine going to get added? Now we know that phenol very easily reacts with bromine at room temperature. So phenol is definitely going to react with bromine, and also the alkene reacts with bromine. Now we know that. So bromine will react with the two parts of this structure. So let's draw the structure. Now when bromine reacts with the phenol part, bromine gets added to the second, fourth and sixth position when phenol reacts with bromine. But we can see that the fourth part is already occupied. Fourth position of benzene is already occupied. So bromine will get added to the second and sixth position. So let's add bromine on the second and sixth position. And next, as I said, alkene also reacts with the bromine. So let's add bromine here also. Now what type of reaction is this? It's electrophilic substitution reaction also. Electrophilic substitution reaction. Also you can call it as electrophilic addition. So you can write either of it. Next is excess of ethanol chloride is the reagent. Now we know that ethanol chloride can be added to benzene directly, but for that we need a catalyst AlCl3 to undergo a Friedel-Crafts reaction, but we don't have a catalyst here. So it's only ethanol chloride. So this ethanol chloride, as we know, it can act as acid also. So it can act as ethanoic acid also. So now let's have a look at that part, that is this reagent acting as an acid and able to react with serotin? Yes, acid can react with alcohol group and with amine group, and so the reaction will again going to occur at the two different groups of the same compound. So let's make a structure. I have already drawn the common part of the compound which is not undergoing the reaction. Now let's have a look at the parts which will react. The alcohol part. Now alcohol when reacts with acid changes to ester. So here we are drawing an ester with the O of the alcohol part and then the acid part. So here will be CO. So I'm adding a double bond O here and a CH3 group of this part. So a CH3 group will have a line here. So a double bond O. This is the ester we are making. Now when acid reacts with an amine, it is going to form amide. So I should write NH here. And then the amide group will be added. So again a CO bond and then CH3. So here is the structure of the product when acid reacts with the alcohol part and the amine group. Now when such a reaction happens where an ester is formed or an amide group is formed, water is definitely eliminated out in such reaction. So what kind of reaction it is? You can call this as condensation reaction because the water is removed, or you can also call it as an addition or elimination reaction, but you can write any one of it. So here we are writing about condensation reaction. So when such a question is asked where only one compound is reacted with different types of reagent, just think that what are the functional groups present in our compound. As we had seen here that we had a phenol group, we had an alkene group, and we also had an amine group at two places, out of which NH2 is very prone to the reaction. So it had undergone reaction at two places. Now, when such reagents are given, think that this reagent can react with which part of the functional groups or how many of the functional groups, and then decide the product accordingly. It may happen that only one reagent can react with two of the functional groups of the same compound. So we need to add a reaction for both the groups. So we have seen three types of questions based on the reactions of benzene, and let's also understand some tips and tricks to solve such organic questions, that is benzene questions. The first tip is learn all the mind maps of benzene reaction. Now all the mind maps means not only the reactions of benzene but the reactions of substituted benzene also and the reactions of phenol also. I would also suggest that learn the mind maps of the reactions of your AS level also, because then they are also included here. Now when you have got a very big or complicated compound, then look for only the functional groups in that compound and just ignore the other parts, because only those functional groups are going to react. So look for the functional groups on a given compound and recall the reactions of those functional groups only, and then keeping in mind the reagents beside your product. Third tip is always draw the structure of the given compound in question fully. Means simplify the structure of the compound if you are given the skeletal form or in some other form. Draw it in the form in which you are comfortable. Then try to understand what change is happening and then only try for the answer. Suppose if still you are stuck somewhere in the question and not able to decide the answer, then try to read the question again. Try looking for any other hints which are given in the question and then think for the answer again. This is really going to help. So what I suggest is learn the mind maps before you solve any types of benzene questions, and then try with the methods which I have discussed in this video. This is really going to help you out.